Welcome everyone. Let us start today's lecture with a question. And the question is, what is the sum of positive integers from 1 to 100? That is, we need to find the sum for 1 plus 2 plus 3 plus 4 and so on up to 100. I would like you to pause the video and think about this question for a while. How would you solve it, or how would you approach to solve it, and possibly how much time would you need to answer this question? Okay, I hope you have given a bit of thought for the approach that you take to solve this question. One straightforward approach would be to just directly start adding everything. So you have 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10, 5, 15, 15, 6, 21, 21, 7, 28. And then you can continue like that until you reach 100, and then you can get to the final answer. But as you can imagine, or once when you start to do this, you will find that it is very, very cumbersome. It will take a lot of time, a lot of writing. You need to keep account of what is the sum until now, and then again calculate many more sums. And surely if I then increase this number 100 to 1000 or something like that, then that approach is no more very practical to take. So one thing that you could see here, if you give this a bit of time, is that if you see the first term and last term, what it is, 1 and 100. So if you add this up, 1 plus 100 gives you 101. Then you take the second term, 2, and the second last term, 99. Again, if you add 2 and 99, it gives you 101. So 1 plus 100, 101, 2 plus 99, 101, again 3 and 98, 101, 4 and 97, 101, 5 and 96 would again be 101. And if you continue to think on this line, then you will see that you will reach 50 and 51, which will again sum to be 101. So which means we are just adding 101 quite many number of times. So if you think that way, then we are taking a pair of numbers, the first term and the last term, the second term, second last term, and so on. So essentially what we are doing is we are adding 101. So how many number of times are we adding 101? So if we keep on continuing, then we will reach 50, and then 50, 51 would be 101. So we would be adding 101 50 number of times. Then effectively what we are doing is we are adding 101 50 number of times. That is 101 multiplied by 50, and the answer would be 5050. So if we just had taken this approach in the beginning, then we can reach the answer very easily. Apparently this is a story of one of the most famous mathematician and physicist called Gauss. You will hear his name many number of times when you study physics, maths, and almost everywhere. So he was a 10-year-old kid when his teacher gave him to solve this question. Apparently the teacher was expecting the students to take a very long time to solve this question, since the students would just keep on adding 1 plus 2 plus 3 plus 4 and so on up to 100. But according to the story, Gauss took this approach and he just came up with the answer within his mind without even writing a single line in his mind. So this also shows that in mathematics, or just in general life, everything depends on the approach you take towards a certain situation or towards a certain problem. If the approach is correct, the answer can be very easy and very quick. So let us write this more formally, what we did. So we have our sum as S is equal to 1 plus 2 plus 3 plus 4 and so on up to 98, 99 and 100. So let's just say we denote this sum as S. Now if we just reverse this thing, what we had said there, like the first term and last term adds up to 100, 2 and 99 adds up to 100. So if we just write this sum in reverse sequence, then we would still have the sum as S. Then we would have here 100, we would have 99, we would have 98, and so on. Here we would have 3, here we would have 2 plus 1. Now if we just add both of these equations, what do we get? S and S, it will be 2 times the sum. 101, it will give you 101. 99 plus 2, again 101. 98 plus 3, again 101, and so on. And again in the end you'll get 101, 101, 101. So what we get here is essentially 101. And since we have 100 terms, so we are writing 101 100 number of times. Therefore 2s is equal to 101 times 100, or s is equal to 101 times 100 divided by 2, or this is 50, and this is equal to 5050. So either you could directly think of this here in this way, or you could think of this sum on this line. Okay, so now let us ask one more general question. What would be the sum of first n terms of an arithmetic progression? That is, what would we get when we add an AP? And an AP is given by A plus D, A plus 2D, and so on up to, if you write the n minus 1 term, then that would be A plus n minus 1 minus 1, that is A plus n minus 2 times D, and the nth term would be A plus n minus 1 times D. Now we need to find the sum of all this term. Now similarly, as we saw in our last example, you could see is if you add the first term and the last term, what would you get? A and A, 2A plus n minus 1 times D. Similarly, if you add the second term and the second last term, then what would you get? A and A is 2A, ND remains ND, and here you have minus 2D, and here you will be adding D. So you again get back to ND minus D, that is again 2A plus n minus 1 times D. Let me just write what we get. We get 2A plus n minus 1 times D. And again, if you take the third term here, A plus 2D, and from the third term from the end would be A plus n minus 3 times D. And if you add both of them, you would again get 2A plus n minus 1 times D. So essentially what you would be doing is you would be adding 2A plus n minus 1D. How many number of times? Half the number of times, because till the time you reach the middle term, the half term, then you would be adding that term with its next, and you would get 2A plus n minus 1D. So the answer would be, we are adding 2A plus n minus 1D n by 2 number of times. So this would be the answer. So let us write this more formally. Our first equation would be S as A plus, second term as A plus D, the third term as A plus 2D, and so on up to the second last term as A plus n minus 2 times D, and the last term as A plus n minus 1 times D. And if we now just write it in the reverse order, so we write the nth term here, that is A plus n minus 1 times D, and here we write the second last term, that is A plus n minus 2 times D, and you can so on write the other terms, and here we will reach A plus D, and here we will have A. Now if we add both of this equation, what do we get? S and S would be 2S. If you add the first term and the last term, A and A is 2A plus n minus 1 times D. 2A plus n minus 1 times d. Again, if you add the second term and the second last term, a and a would be 2a, and here you would have nd minus 2d, and you are adding plus d here, so it will be nd minus d, that is n minus 1 times d. So you would again get 2a plus n minus 1 times d, and so on. If you add these two terms, you would again get 2a plus n minus 1 times d, and again if you add this, you would get 2a plus n minus 1 times d. Therefore, what we get here is 2s is equal to, we are adding this term 2a plus n minus 1d n number of times. There are n terms, so we are adding this n number of times. Hence, this will be equal to n multiplied by 2a plus n minus 1 times d. Therefore, the final sum that we have, we can also write this as Sn, denoting that it is sum of n terms of an AP. This is equal to n by 2 times 2a plus n minus 1 times d. So this is what we reach here following this approach. So either you could have thought of this formula directly here in the beginning, or you can think of it in this process, and you can reach to this final formula. So few things to keep in mind here is that you don't have to learn this, you don't have to remember this formula. One way to just think about this formula is, if you add the first term and last term, what would you get? 2a plus n minus 1 times d. This is what we have here. And similarly, if you keep on adding the second term and the second last term, you'd keep on getting this expression 2a plus n minus 1 times d. And what you are doing is you are adding this 2a plus n minus 1d half the number of times there is total number of terms. So 2a plus n minus 1d times n divided by 2. This is our formula. A few things to notice here is that if we write this formula as n by 2 times a plus n minus 1 times d, then this expression here is essentially just the nth term, right? Nth term. So let us say there are n terms in an AP, that is Tn is the nth term or the last term of the AP. Then we have our sum for that given AP as S is equal to n by 2 times a plus last term. So if you just know the first term and last term of an AP and the number of terms there are in AP, that is, if you do not know the common difference, you can still find the sum. One more thing to keep in mind is that this formula consists of n, a, d and s. So there are 4 variables here: sum of AP, the number of terms, the first term and the common difference. So if we know any 3 of these things, then we can find the 4th term or the 4th variable. So if we know, let's say, the number of terms, the first term and the common difference, we can find the sum. If we know the sum, number of terms, the first term, then we can solve for the common difference. We will solve more examples in the coming lectures, so this will keep on getting more clear. One more last remark. Let's say we have an AP given by a plus d, a plus 2d and so on up to, let's say we have n minus 1th term as a plus n minus 2d, and we have nth term as a plus n minus 1d and so on. Now let's say we know the sum of first n minus 1 terms, that is we know s n minus 1. We know the sum of first n minus 1 terms, and we also know the sum of n terms, the sum of first n terms, and we want to find the nth term. Can we do this? Yes. How do we get to Sn? If we know the sum of n minus 1 terms, then if we add nth term to this, then we will get sum of n terms. That is, if we have Sn minus 1, that is sum of n minus 1 terms, and if we add the nth term to it, that is Tn, then this should be equal to sum of n terms. Or we can write this as Tn is equal to Sn minus 1. That is, if you know the sum of n terms and you know the sum of n minus 1 terms, then the way to get the nth term is by subtracting both of this. This is just a remark, and in our coming lectures we will solve some more examples, and then we will get familiar with the formula that we derived today and the facts like this, and we will get to see many more interesting patterns that we could observe and solve many interesting real life questions in the coming lectures. You can find all the lectures on arithmetic progression in this playlist here, and also the lectures on pair of linear equations in 2 variables in this playlist here. Also, please subscribe to the channel and share it among your friends. Thank you.